Hello and welcome to the next unit of Pre-Calc 11. So we are doing quadratics. For this video you might hear some interesting stuff. I don't know how much of the background noise is going to pick up. I'm actually doing this from the classroom, so you will get the authentic classroom feel for this teaching. We'll see if we have any interruptions. My door is locked, so hopefully no one's going to come around, but we'll see. So quadratics, let's dive into this. So first, we're going to review linear functions. This one's going to be pretty quick. So here is your function. This is a typical kind of function. You'll recall here, this is your general equation, y equals mx plus b, m being your slope value, b the y-intercept. So this is your general equation. From this, we can graph fairly easily and quite quickly. So I'm going to go through this really quick, since you should have learned this already. So here's our expression, y equals 2x minus 3, 2. I can think of this as 2 over 1, and this is my slope. So if my slope is equal to 2 over 1, this is also equal to your rise over the run. So this means I'm going to go 2 up, 1 to the right. And negative 3 here, this is my y-intercept. So when I'm plotting this out, I plot my y-intercept first. I go down to negative 3, so negative 1, 2, 3. There's a point. And then from there, I do my slope. So up 2, right 1. Up 2, right 1. And so on and so forth. Up 2, right 1. And then at this point, you connect the dots with a ruler, which I need to grab something similar to a ruler since I don't have a ruler right beside me. Hence, you'll need to have a ruler for linear lines. So, straight line, arrow. Don't forget the arrows, you need to include those. I'll do one more example, but this is not the main thing I want to focus on. So again, my y-intercept here is 6, so I go up 1, 2, 3, 4, 5, 6. It's up here. And my slope is negative 3. Negative meaning I go down. So I'm going to go down 3, right 1. So down 1, 2, 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. So on and so forth. So there is my linear line for this. Connect the dots. Put the arrow. If you don't put the arrow, you'll lose marks. So make sure you do that. Then we can look at some quadratic functions. So I'm just going to show you some of these. It says to use a graphing calculator. Please do not buy one. They're over £1,000. It's not worth it. So what you need to do if you want to be able to double check some of these answers is there's an app that you can get on the phone called Desmos. So instead of your graphing calculator, use Desmos. You can download this. There's a website you can use as well. It's free, so it's a lot cheaper. So from that, we can graph some of these. So x squared is going to look something like this. It's a sketch. It's not precise. So include the arrows. This is what it looks like. Note this one, because it's positive, x squared, it's going to open up. So it's a smiley face. It's positive, so it's smiling. Negative x squared looks like this. It's negative, so it opens down. If you're negative, typically you frown. Not always, sometimes. Then if we do something like this, so it's positive, it's opening up, but the negative 6 tells me it shifts down 6 spots. So it's going to be something that looks like this, where this point down here is at negative 6. And you can keep going on. So this one is going to open down because it's negative, and this up here is going to be 6. Now, these ones, I'm just going to graph it, and later on we're going to figure out what that looks like. So you're going to graph it. It's going to look something like this, and the other one here is going to look something like this. So these are just rough sketches. I'm not going to go through in exact details what those look like, but That's what those are. So when we are doing, when I give the instruction sketch will mean rough draft. Typically, if I want to accurately sketch, you need to actually graph it. So one way to do this is making a table of values. You should know how to make a table of values. You set up two columns, x, y, and whatever your equation is, you're going to solve for something like this. So for x, we can put in points, -2, -1, 0, 1, 2. You can pick any x values. These are just in general the 5 I use. They give you a pretty good gist as to what your equation should look like. Then you plug them into this equation. So -2 squared gives you 4. -1 squared is 1, 0, 1, 4. So I can plot those points. -2, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4. So there's my graph. Connect the dots. There you go. That's what your quadratic function is going to look like. Now, something interesting with this is you'll notice a pattern with how I plot this out. You'll see this a little bit. Try and see if you can figure that out as we move on to these questions. So -x squared. I could do the same thing, except negative, all that does is flip what we've got. So if I did the table of values, it would just simply flip what the y values are, and it becomes negative. Remember, negative means it flips down. So I'm going to have these points here. So -2, 1, 2, 3, 4, -1, 1, so on and so forth. Once you do one side, the other side's pretty easy. With quadratics, they're symmetrical, so once you get one half, the other half looks the same. So notice here, I go across 1, down 1, across 1, down 3. And then if I were to keep going, I'd go across 1, down 5, across 1, down 7. So there's going to be a pattern with this. Let's try x squared minus 6. So all I do is take my x squared, and when I minus 6, I'm going to make the y value 6 less than that. So I'm going to start at -1, 2, 3, 4, 5, 6. Here's my vertex. Again, I'm just taking these points, shifting them down 6, down 6, down 6. So I'd get 0, -6 here. Then I'm going to move across 1 to get to here, up 1. Across 1, go up 1, 2, 3. Across 1, up 1, 2, 3, 4, 5. So I'm going up by increments of each consecutive odd number. So across 1, up 1. Across 1, up 3. Then up 5. And this gives you the nice quadratic. So again, first I go up 1, then I go up 3, then I go up 5. So basically, what you can do is, if I'm looking at whatever I'm talking about, so wherever your vertex is, so let's say here's my vertex, I'm going to be moving out 1, up 1, then out 1, up 3, out 1, up 5. And this is kind of the pattern that you're going to see for each of these dots. Same thing, if I go to the other side, I'm going to go left 1, up 1, left 1, up 3, left 1, up 5. So this is just a shortcut. Once you figure out what your vertex is, it's pretty easy to figure out the next points without doing a table of values. Let's see if I can do it with this one. So I've got +6 is my vertex now, and I'm going to go down. So I'm going to go across 1, down 1, across 1, down 3, across 1, down 1, 2, 3, 4, 5. Same thing on the other side. 1, 1, 1, 3, 1, 5. So connect the dots, arrows. So pretty straightforward. Once you notice this pattern, it's not too bad. So next page, I want to do something called complete the squares. The reason I want to complete the squares is if I can get this, which is a completed square form, or it's called the vertex form, this actually tells me exactly where the vertex is. And because I can use that nice trick of going out 1, up 1, out 1, up 3, out 1, up 5. Because I know that pattern, once I have the vertex, the rest is easy. Not too bad. However, I need to show you how to complete the squares. Some of you might have seen this before, but I want to show you how to do this. I'll do one example here. So, completing the squares, what you're going to do is do the following steps. So first of all, I'm going to split up my equation. So I split it here, right after the x to the power of 1 term. And what I want to do is, I want to turn this into a perfect square. So what I essentially want for this is I want to take this term, what's in front of the x, and divide it by 2. So 4 divided by 2 gives you 2. So I want to get this. Whatever this term divided by 2 is, I want to get x plus that term all squared. So if I do this, x plus 2, what do I need to get with this? So as I multiply this out, x squared plus 2x, so I'll get plus 4x, plus 2 times 2 gives me 4. So this would give me a perfect square. Now, on this side of my equation, on the left of this line here, I don't have that perfect square. I just have x squared plus 4x. So what I'm going to do is I'm going to add 4 onto that side of the equation. So y equals x squared plus 4x plus 4. But I cannot just simply add 4 to an equation. That changes the equation. So on the right side, I have this plus 6. I am also going to subtract 4 to get rid of the 4 I added. That way I'm not actually changing the equation. So this now over here is a perfect square. Y equals, this side equals x plus 2 squared. And then on this side, plus 6 minus 4 gives me plus 2. So this is now in a completed square form. So with that, these two values here now tell me what my vertex is. So this one, inside the brackets, tells me that my point is at -2 because it's the opposite of this one. As it shows here, it's x minus p. So I need the opposite of that one. And then the other term is just simply positive 2. So you take the opposite of this one and what that one is. So this is my vertex point. That's why this one's pretty handy. So I'm just going to go on to another one here to graph it, so I don't make the video too long. If you want to see some more examples of this, you can ask me in class and I can go through that. So here's one, x squared minus 6x minus 5. So again, the process is split your equation right after x to the power of 1. I want to turn this side into a perfect square, so I'm going to take the term in front of the x and divide it by 2. So -6 divided by 2 gives me -3. So I want -3 squared. Expand this out. I should get x minus 3 times x minus 3, so I'll get x squared minus 6x plus 9. So I need to add 9 to make this side a perfect square. So y equals x squared minus 6x plus 9. I cannot just simply add 9 to my equation. I need to also subtract 9. And again, the minus 5 comes from here. So this part's my perfect square. Y equals x minus 3 squared. Subtract this one, minus 14. So therefore my vertex is at 3, again the opposite of this one, and minus 14, as such. So now we want to plot this. In order to plot this, I need to put the vertex on here. So there's not 14 boxes, so I'm going to see if by 2's work. 2, 4, 6, 8, 10, 12, 14. I can make this work. So I'm going by 2's. This is minus 2, minus 4, minus 6, minus 8, minus 10, minus 14. And then over here, I'm going to go by 2's as well, just to make this easier. 2, 4, 6, 8. So 3, negative 14. That goes here. So again, my rule is go out 1, up by 1. So here's my vertex. I go out 1, I go up by 1. Now we're using half boxes here, so it's a little bit hard to see that. I'm going to go out by 1, out by 3. 1, 2, 3. Out by 1, up by 5. 1, 2, 3, 4, 5. Out by 1, up 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So that's how that works, how you'd get that. So put these dots. I'm just doing the making it symmetrical. And then connect the dots. So there is my parabola.